And let's see if we can follow the directions. So we're going to eliminate the parameter for this problem right here. This is problem B, page 51, 6.3. We're going to eliminate the parameter and identify the curve. And then I'm going to show you how to do this on your calculator. In case, I don't think we did this before, so we'll do it on our calculators. But first we're going to eliminate the parameter. Now, who remembers how we did it yesterday? Jordan?
It's kind of like a substitution problem.
That's exactly how we did it. So we took one of the equations and...
Yeah, so in this like equation, I would subtract from y, subtract 3 from y.
So you're getting t by itself.
Yeah.
Yeah. And then plugging it in.
Yeah.
Right? Now, he said what we did yesterday, and he's exactly right, was like substitution. What about elimination? Can elimination be used? Actually, it can, and the way this problem is set up, it would be super simple to just add them together. Do you see what's going to happen if you just add them together? You're going to get x plus y, you're adding, equal to 5, and then what happens to the t's? They're eliminated, they're gone, which was the goal. The goal is to eliminate the parameter. Now, could I have substituted and gotten exactly the same answer? Yes. So do it with substitution if you like, do it with elimination if you like. It doesn't matter. Either one. So if we had substituted like Jordan suggested, he said, I think you said subtract 3 from both sides. So you said solve for t here and then plug it in here. So x equals 2 minus y minus 3. Now if you do that, you're going to have to be careful to distribute the negative. So x equals 2 minus y plus 3. So x plus y equals 5. Is it exactly the same? Doesn't matter. You do it however it makes sense to you. But the objective is get rid of the t's. So you're either going to substitute it out or you're going to straight up eliminate them. Okay, what shape is that? If I graphed that, what would that be? It's a line. That's a line. If you're unsure, think about it as negative x plus 5. Can you see it? Y equals mx plus b. That's a line. All right, get your calculators out. Now, we're going to be making some changes on your calculator that you need to remember you made, okay? All right, everybody hear me? You're gonna want to change some things back to do other operations on your calculator. All right, so here we go. First thing I want you to do is go to mode. And for me, it's the 4th row down. I'm not sure if all the calculators are the same, but I see PAR. PAR is an option in one of my rows. Do you see it? Highlight it. PAR stands for parametric. Okay, got it? Now go to window. And all of a sudden now, it looks different, doesn't it? It's saying I need to know T min and max. Down the line, there was also X min and max, just like we had before, and Y min and max. For purposes of just getting started, let's set all the mins. So T, X, Y, min at negative 10. And all the maxes at positive 10. So negative 10 to 10 for T and X and Y. Just like all graphing, sometimes we're going to need to change those. Now, the other one I need you to change or to put something in for is T step. For T step, put in 0.1. 0.1. We'll talk about that in a minute, but I need you to make that 0.1. Okay, got it? Now, press y equals like you're going to put in an equation. And that looks different. You press y equals, but now what does it say? X sub 1t, y sub 1t. So you're going to put in this equation for x. So you're going to type 2 minus, now, press your variable button, the button you normally press to get x, what happens when you press it now? You get t, because you're in parametric mode. So your variable is going to be t. And then for y, put in 3 plus t. And then hit graph. Did you get a line? Did you get a line that has a y-intercept at 5 and a slope that's negative? Isn't that cool? Yes, exciting stuff. All right, let's try the next one. We'll graph it too, so hang on. If you have a question, we'll get to it. All right, so now we're going to do this one. Step 1, eliminate the parameter. Now, you're not going to be able to add these together. I'm going to have to do substitution, right, Jordan?
Yeah.
Yep. So what would you suggest I do for substitution?
Subtract 2 from y.
Now, be careful. If I subtract 2 from y, which is fine,
yeah.
but that's, I'm substituting now, or that's a negative t, right? So I need to change my signs. So negative y plus 2. Is that okay with everybody? Gotta get t by itself. Now we're gonna plug it in here. So x equals, negative y plus 2 squared. What'd you say?
Parabola.
It's a parabola. You are exactly right. Now, Olivia, it's a different kind of parabola though. It's a sideways one. Which, oh, by the way, boys and girls, is not a function. So do you remember when you switched your calculator to PAR mode? What was it on originally? When you made that switch, when you clicked over, it was on function mode. This problem wouldn't be graphable in function mode because that's not a function. But now that we switched it to parametric mode, we can graph it. So you don't make any changes, just go to y equals, take out the old equations, and put in t squared and 2 minus t, and hit graph. And do you see a beautiful little sideways problem? Now, everybody got it?
No.
Type in your 2 equations.
I'm not.
Now, I want you to go back to window for a minute, and we're going to talk about what that step thing does. So go back to window, make the step 5. So where it says T step, make it 5. Now press graph. Very odd, right? Now, let's go back to T-step, and let's make it, what was it originally, 0.1? Let's make it 0.01. 0.01. Now wait. Now, the first thing you noticed is it took it longer to graph, right? Now, I want you to listen to me because this is going to be important in our next section too, when we get to the polar coordinates. This is going to be important. What the calculator is doing is dealing with 3 variables. It is calculating x's and y's based on a t value, right? So if you said, let's let t be 1, then it would calculate x is 1 and y is 1. And if you said, okay, I'm going to let t be 2, then x would be 4 and y would be 0. Agreed? Now, when you say t step, you're telling the calculator how big of steps to take in the t's. Now, these are steps of 1. But when we had it at 0.1, it was putting in 1, and then 1.1, and 1.2, and 1.3, and so on. What happened when you put in 0.01? It was putting in 1.01, 1.02. Do you understand why it took longer? It's plotting way more points. Now, what happened when we made it 5? It was skipping, right? It was going 0 to 5 to 10. It was skipping. And so what was happening is you weren't getting as many points, and it looked more jagged, didn't it? Look more jagged? So the moral of the story is T-step is going to control the accuracy of your shape. But if you make T-step too small, it takes forever. You get a great graph, but it takes forever to graph. So you want to kind of find that balance. And usually 0.1 is a pretty good estimator. But if you ever get jagged edges, then you know, oh, my step's too big. I'm going to have to make it smaller. Okay? All right, let's do one more. So this is a parabola. We graphed it. We got a parabola. All right, let's do this last one. Okay, so what's your thought? Your job is to eliminate the parameter. So what are you going to do? We're going to graph it in a minute, but first we have to follow the directions. We want to write an equation with no t. Yes, so x minus 1 equals t. And then we'll put that right here. So y equals x minus 1 squared minus 2. Is that okay with everybody? Now that's a parabola, right? Which way does this one open? Ah, very good. Where's its vertex? Positive 1, negative 2. Let's see if that pans out. Let's graph it. Don't change. Oh, wait. Did I change your mode or change your window back to 0.1? Your t-step. Otherwise, we'll be here forever. So what are my equations? X equals t plus 1 and t squared minus 2. Did you get what you thought you should get? A parabola opening up with a vertex at positive 1, negative 2? Is that what happened? Aren't you glad you came in this morning? Look at what you now know how to do. That's awesome. Okay. All right. Just remember your calculator is now in parametric mode. It isn't going to graph normal stuff until you move it back to function mode, right?
So what were we supposed to put in our calculator? I got one opening down.
Your parabola opens down?
Yeah.
You put that equation in and that equation in?
T squared minus 2, yeah.
And you put in x equals t plus 1? I'll have to look at it because I don't know how that could possibly happen.
I got it.
Okay. All right. Okay, now the last section. Says write the parametric equations of the line through these 2 points. Now, you all know how to write the equation of a line. You find the slope, right? Y minus y equals mx minus x, or y equals mx plus b, whatever your thing is. But we're not doing that. We're writing the parametric equations of the line. So that means you got to come up with an x equals and a y equals that describe the line. Now, if I were you right now, I'd be a little bit panicky because it's like, whoa, how in the world do you do that? It is so easy. Here's what I want you to do. I want you to write down this framework. Just write down exactly what I write right there. And then I'm going to tell you what goes where. And you're going to be amazed at how simple this is. But this is the framework you start with. This is actually called the vector form of a line. This is the vector form of a line. And it's simply xy equals a parentheses plus t times a parentheses. First parentheses right here goes either point. So I'm just going to put 1, 2 there. Either point will work. There's more than one acceptable answer to this problem. So don't worry. Pick one. Now, the biggest mistake that's made is kids put the other point here, and that's not what goes here. What goes here is the vector AB, the actual vector. So a point goes in the first blank, but the vector goes in the second one. So what is the vector from A to B? 2, -6. So what goes in the first parentheses? Either point. What goes in the second parentheses? The vector from A to B. Now, to write these, it's very, very simple. Notice how you've got like 3 ordered pair things here? Write an equation for the first parts. So in other words, just look at the first part. X equals 1 plus 2t. There's your x equation. X equals 1 plus 2t. I'm just looking at the front part of each parentheses. That's the x part. So what do you think the second equation is going to be? The y equation. Y equals 2 minus 6t. And there are your parametric equations for the line. There are the parametric equations for the line. That's all there is to it. So let's look at the next one. We're going to do the same thing. Our format that we're going to start with is xy equals a parentheses plus t times a parentheses. Okay, here we go. What do you want to put here? 3, 6. Now what goes here? Be careful. It is not -1, -2. Do not put -1, -2 here. This is going to be the vector, which is, did you say -4, -8? So what are your answers? X equals what, Christina?
3 minus 4t.
Okay. 3 minus 4t? Christina, can you give me y? What would y be?
6 minus 18.
Perfect. There it is. Two more. Can you try those on your own? Can you try to get a set of parametric equations for these two lines? Remember, the final answer is x equals and y equals. Those are your parametric equations. Anybody comfortable coming up on video? Jordan, thank you.
Come on, guys.
You in the first one?
I got another one too.
What do you think about Jordan's? Is that okay with everybody? Now, could you have a different answer?
Yeah.
Yes. What part of the answer, though, would be the same? Wouldn't the t part be the same? But you might have, instead of -2 and 0, you might have 1 and 1. And that would be okay. If you graph them, they'd be the same line. Okay, Christian, you okay doing this one? Thank you,
Yeah.
Jordan. What do we think about that? Everybody okay with that? Good? Okay. I really want to get your other quizzes graded and back to you, but we have one more quiz to take. And so I'm thinking we'll revise the plan a little bit. We'll start going over this today, this practice quiz. And then we'll finish it next time and take the quiz next time also. And start doing our review. We just have 2 days of review and then we have our class. So things are flying along, thank goodness. Well, I gave you a practice question yesterday.
40, because it's 40 for the next class and we started.
How many questions did
Somewhere around 40 or 50. I mean, it's big, I just didn't know the whole test. Okay, now, notice this practice quiz, which we are going to start today. We won't finish it, we'll finish it next time. I'll turn back the quizzes you took today so you can see what you missed on that. And then if we have time, we'll go ahead and take the quiz next time. And then start reviewing with our practice quiz. But notice that this quiz has a lot of the same stuff on it, doesn't it?
Yeah.
That's why I want to get that other one back to you so you can see if you made a mistake. But let's go ahead and get started on this practice quiz. Many, many, many of the same problems, but a couple of new things stuck on here. So here we go. Let's see if we can get part 1 done anyway. So we need the vector. I think we have 5 more minutes. We can get part 1 done. Okay, so we want the vector AB. That's it. Easy peasy. Don't miss this. The vector from A to B is 9, -1. You are perfect. Now, B is a new question. B is asking me for what? The dot product. All right, now we've talked about that. Do you remember how to find a dot product?
Multiply the x's plus then multiply the y's when you add them together.
Did you hear? Multiply the x's, multiply the y's, add them together. So multiplying the x's would give me -4. Multiplying the y's would give me 6. Adding them together gives me the answer, which is 2. Okay, Chloe, how do we find a dot product? Exactly, multiply the 2 x's together, multiply the 2 y's together, and add. Caitlin, you alright?
Yeah.
Alright, and then C, this is a big, there's more going on here. So let's make sure we're doing stuff in the right order. What would you do first?
Find the scalar for V.
So find 2v. Did you hear? He even called it a scalar. He said we're going to do the scalar multiplication. We're going to take 2 times v. So 2 times v,
2, 4.
what's v? 2 times v would be 2, 4. Is that all right? Then what? Add u. So we're going to add -4, 3 to that. Okay, what do we get? We're adding now. Just
-2, 7.
thank you. And then what? There's one more thing that has to be done. Find the magnitude. And to find magnitude, we square the first one, square the second one, add them together, and take the square root. So the final answer is root 53. Okay? All right. Let's pause there. We'll pick this up tomorrow. Oh, I love it. I get to see like 3 or 4 days in a row. It's awesome. So tomorrow